All right, welcome. I'm going to get started in a second. I need to send out the link really quick. So give me 1 second. Nope, not that. Link. Add link. Why are you not letting me add the link? And part of the reason why I want to do this is I'm trying to learn how to just stream in general. So let's see, we got, where is it? Copy, that's fine. We'll do it this way. My channel. Copy. Link. Add link. There we go. All right. Okay, so here's my plan. I wanted to go over week 8's homework, the classwork, and we're also going to do a little bit of today's work. So we did 3 Desmos activities. My plan is just to go over them. If there's any questions, throw them in the chat. I got my eye on the chat. Or you can send me, if you're one of my students, you can send me an email and I'll keep an eye on my email box, my inbox, and I can go over any specific question. That goes for Delta Math, our Desmos activities, and anything before Delta Math. Okay, so I'm just going to jump right over to. All right, so let's get started. Remember, I'm just gonna run through really quickly our Desmos activities that we did in class. These were our lessons. You were supposed to finish these for your homework. All right, so for our warm-up, right, we talked about exponential functions. We were given exponential functions y equals a times b to the x, where b is greater than 0. I was asked, what does a represent in the equation? Okay, so remember the a in our in our equation. So let me pull up Desmos over here. Open up a separate thing. So we have y equals, all right, so a times b to the x. All right, so what's going to happen is that number here, let's just call this 3. This number here, a, is going to be, that's supposed to be to the x, sorry, is going to be where our y-intercept is. So a is going to be our y-intercept. So we can say a represents the y-intercept. And b is going to be our common ratio. So b represents the common ratio. Right? So those are 2 things that you were supposed to be able to determine from our equation, right? And our common ratio is just how much we multiplied by. So if I were to go ahead and make a table, and I want to replace, let's do this. I'm going to use this table here. I'm going to use this rule here, and I need to make this x1 so I can input my x's from this column into my equation. So let's do 0, 1, 2, 3. We'll just go a couple. All right, so if you zoom out just a little bit, we start with our y-intercept of 2, and then our base, our common ratio, is how much we're multiplying by each time. So as I'm going from 2 to 6, we're multiplying by 3, and from 6 times 3 is going to be 18, and 18 times 3 is 54, right? So that's just our quick warm-up. So we talked about warm-up number 2. We want to write an equation and sketch the exponential function that has a y-intercept of 2 and triples after each interval, right? So is that Michael Rankin in my class? All right. All right, so we have exponential functions that has y-intercepts, right? So let's go ahead and start by graphing this. All right, so let's do, my y-intercept is going to be 2, and we're tripling every single time. So as I'm going over 1, I'm going to be multiplying this by 3 because we're tripling. So we're going to 2 times 3 is going to be 6. And we're just, again, this is just a sketch. So it's going to look something like this. It's not perfect. Ooh, that was terrible. Let's try that again. Let's try that again. Try and get my 2 dots closer. Again, not perfect. Again, right, and then we're just going to write our equation, right? So we have y. We said our y-intercept was going to be 2, base of 3, and we're going to raise that to the x power. So we go and zoom in just a little bit more so we can see this a little easier, right? Okay, so those are 2 warm-ups. Right. So again, if you have any questions, go and throw those in the chat, or you can send me an email, and I'll be able to answer any homework questions that you might have. All right. So this was our notes. Remember, I wanted you to write this down just to remind you. And what you were supposed to do is we're going to start experimenting with our exponential functions, right? We were trying to start typing out our equations. So we had a y-intercept of 4 and a common ratio of 0.5. So what you had to do was just write in y equals 4 times 0.5 raised to the x, right? And then you were going to just take a look at this. Okay, we'll see what's happening here. And then again, y equals 7 times 0.25 raised to the x. There's my exponential function here. And then the last one is y equals, my y-intercept is 2, my common ratio is 0.75, and I'm raising that to the x. Okay, so there's that. All right, so the last thing is, based on what you saw in our last 3 problems, I wanted you to, we've been looking at exponential functions when the base is greater than 1, right? So for example, here, right? So our base is bigger than 1. I could change this number to any number, like say this is 4 or 5, 6, anything that's bigger than 1. We're going to get a shape that looks like this. But now we're starting to look at stuff when our base is between 0 and 1. So our general shape for this is going to look something like this. And this is called exponential decay. Right? We're going to have what will happen to the exponential graph if we look at the values between 0 and 1. The graph, you can say something like the graph will go down. The graph, something about like the rate of change is negative. Something like that, right? All you had to do is write in some sort of observation here, right? Okay. The problem is when we start thinking about negative exponents. If you notice, the graph disappeared. Like the graph doesn't exist. Well, it's not a continuous function when it's less than 0. So we're only going to focus on numbers that are bigger than 0, and specifically when we're between 0 and 1, it's going to be a exponential decay, and when it's greater than 1, it's going to be exponential growth. Which is our next slide, is going to be our notes, right? I gave you this notes. You had to add this right here. When b is bigger than 1, we're going to have a shape that looks kind of like this. It's not going to be this every single time. It's going to be slightly different. We might have a different y-intercept. If this is really big, it'll be really close to our y-axis. So it just kind of depends. But in general, you're going to have a shape that looks like this. And that's going to be called our exponential growth. We call exponential decay when it's between 0 and 1. Remember, this is all for when our general form is this. So when this number is between 0 and 1, it's going to look something like this. Okay. All right. So there's the notes. We got like a couple more slides. This is just what we did in class together. All right, so you're supposed to play around with this now, right? So remember, this was just a sliders. So like you're supposed to hit launch, and you'll see like we want to get all 4 stars, right? But on the next 2, you're supposed to adjust the equation to make it work, right? So see, all right, so this looks like it's going to be an exponential, like we want it to be exponential growth. So I know I need this to be bigger than 2, but I might need to change, I don't know, let's try changing the y-intercept. Right, so let's try that. That's pretty close. Well, what if I want to make this a little steeper? All right, let's try like 3 or 4. 4 looks like it might work. Let's try it. So we're just looking and trying to adjust the equation to make it so we can get all 4 stars. So I used 2 to the 4th. Like it could have, there's a couple different things that could have worked. Like this might have, yep, that would have, no, that would not have worked. Let's try 5. Or I don't know, let's try 9. Yeah, see, like there's more than one answer here. There wasn't going to be a perfect equation for this. I just wanted you to try and play with it just so you can see what's happening as we go through and change each number in the equation. So the last one, this was from last week on Tuesday and Wednesday. All right, so now we have like, it looks like a exponential decay. So I need to flip this. So instead of multiplying by 2 every single time, we're going to be dividing by 2. So I need to change this number to 1/2. Let's try that. Okay, perfect, right? So we got them all. We could have also done like 1/3, and that would have been a little closer. Yeah, you might hear some thunder in the background. So sorry about that. My dog is not happy about that. All right, so yeah, so that was our classwork that we did on Tuesday and Wednesday. Then we have our exponential functions and graphs, right? This was from our class, our Thursday and Friday of week 8. So we want to first write the equation for the graph on the left. Remember, this is in this unit, we're trying to determine the difference between linear and exponential functions. Like we have to be able to tell the difference between from a picture, from a table, from a graph, and you have to do all 6. So there's a tables, graphs, and rules for linear stuff, and tables, graphs, and rules for exponential functions. All right. So again, this is a linear function, right? It's a line. Right, so we want to start with our y-intercept, right? So the easiest way to do this is we just use our slope-intercept form, right? Because if we can find the y-intercept and our slope, we have our equation. So we have y equals mx plus b. So this is going to be, our y-intercept is going to be -2. So see how I'm crossing right here at 0, -2. So I'm going to change this plus b to -2. And then I need to find my slope. And I'm just looking for 2 points. So I'm going to use the x and y-intercept to help me out. So I'm going up 1, 2, and then to the right 1, 2, 3. So my rise is 2, my run is 3, so my slope is going to be 2/3. Right? So you can go ahead and insert your own reasoning. Like, how did you do the problem? What were you looking at? I'm looking for my y-intercept. I'm looking for my slope. Explain to me, how did you find your slope? How did you find your y-intercept? If you wrote in standard form, tell me how you did and wrote it in standard form. You can do that. It's going to take a little more time, but it'll also work. Okay. All right. So just a reminder on our notes. All right. So we had the number 3 to keep the positive. All right. So we wanted to change this number. Oh, okay. So this was kind of like, I actually did this backwards on accident. This was our Tuesdays and Wednesdays homework. We did Thursdays and Friday last. So this is going to be a little bit behind. So notice what's happening as I change this number. You can look at my y-intercept here. You can see what's happening here. So when I change this number here, it's just going to tell me where my y-intercept is. So 3, my y-intercept is 3. And you can also see 0 equals 3. 4, 5. It's just as I'm increasing it, my graph is going up. So this number here is going to be where your y-intercept is. So if there is no number, it's just 1, right? 1 times 2 to the x is just going to be 2 to the x. So same thing here, right? So you're seeing as I'm increasing this number between 1 and 5, it's just slowly moving up. And we're going down. Okay. All right, so what do you notice, right? So you want to say something like A controls the y-intercept. Okay. All right, so we added this one little line to our notes. And then we're going to do the same thing, but now we're going to deal with our base, our common ratio, which is this number here, right? We're going to start changing this number. So to 5, really pay attention to what's happening in this table here. Like 4, so notice how it's like 3 times 4, 12 times 4, 48 times 4. If you do 2s, like 3 times 2 is 6, 6 times 2 is 12, 24, 48, 96. 3s, 3 times 3 is 9, times 3 is 27, 81, 243, right? And again, we're just messing with B here. We're not we're not going below 1. But you notice how my y-intercept stays the same? But as I'm changing this, let's add a little line here. Let's create a table here. Let's do, so I want to do f of x1. We're going to change this to f of x. Make this a function now. So 0, 1, 2, 3. Right, so if I were to change this, we're going to step by 1. We're going to go from 1 to 5, sure. So if we're at 2s, say we're multiplying by 2 every time. If we're at 3s, we're multiplying by 3. 4s, we're multiplying by 4. So on the next slide, you just need to say, hey, B is controls much I multiply by. So remember, we're coming from this after studying sequences. So our first number of the sequence would be something like our 1. And we want to multiply that by 4 to get to our second number of the sequence, would be 4. Our third number of the sequence would be 16 because we're multiplying by 4. Right. So geometric sequences and exponential functions are very, very related. All right. And then we just wanted to add that. So B is our base. It controls the common ratio, or how much you multiply each time by. So if you're dividing, you're just going to write it as a fraction. So if I'm dividing by 3, I'm going to write it as, say, 1/3. But we'll talk about that more later. All right, and the last thing we want to do is we had a card sort. So we had all these rules. And I didn't do a very good job at setting this up, and that was my fault. So I'm going to go ahead and just rearrange this. I want to put, next time if I ever do this again, I'm going to have like a little more information for you. But if you click on it, you can actually see like, hey, I'm crossing my y-intercept at 1. So I know this one's going to be one of where my y-intercept is 1. So it could be this one, it could be this one, or it could be this one. So I have a base of 2, a base of 3, and a base of 4. If I look at this one more time, right, so we're starting at 1 at one place. We're going up to 4. So I'm multiplying by 4, right? So we started at 1 and we're multiplying by 4 to get to 4. So this is going to be with my 4 to the x. Right? So I'm trying to show you how I would do these types of problems. So if I look here, okay, we have a y-intercept of 3. We only have one that has a y-intercept of 3, so that makes it pretty easy. There we go. Move that out of the way. Oh, another y-intercept of 1, so it's going to be one of these two. Let's take a look a little closer. We go to the next line, it's going to be up to 3. So yeah, 1 times 3 is going to be 3. 3 times 3 is going to give us 9, which is going to be right there. So this is going to be my base of 3. Perfect. All right, and then my last one, this is a y-intercept of 1. Again, we're multiplying by 2. So 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. So you bring that over. And then our y-intercept, right? So we have a y-intercept of 2. This is going to be, remember this number right here is our y-intercept. And voila. All right, so that is everything we covered in last week. This is going to be week 8 at this point. I'm almost pretty much done with our in-class stuff. It takes a little bit longer when you're trying to work through everything with 34 students. So I'm just quickly going through this by myself, I guess. If you have any questions, any of my students, feel free to email me or throw something in the chat. All right, so this is what we did today, the last 2 days. All right, so we want to describe and sketch the graph. So y-intercepts, rate of change, common ratio, or common base. All right, so we have, first we want to talk about like what type of function is this? All right, this is going to be an exponential function. And the way we know that it is an exponential function is the way it's set up. We have x in our we have an exponent. This is x is our variable, is our exponent. So when we do this, just a quick review. Remember, there's 2 ways we can write an exponent in Desmos. You can write y equals, this is going to be 6 times 2. All right, the way I like to do this is I like to press the numbers shift and the number 6. So I'm going to go ahead and show it to you with a second camera really quick. So don't mind the happy camera part. All right, so I'm going to hit shift and then the number 6 at the same time. So I'm holding with my pinky the shift, and I'm going to hit the number 6. It looks like a caret button. Like you can focus. Your focus needs more focus. Come on. It's a really, really bad camera. But anyways, it looks like a little caret. I'll write it on the screen there. Hold up. Let's try that again. All right. So it will look like a little like caret button. The button you're looking for. It's going to look something like this. Right? That's kind of, it's telling you I want to put it up, put my exponent up, put that number right after it up in the exponent. That's one way. And the other way you want to do this is we're doing 6 times 2. If you hit the keypad, you hit A to the B, right where my face is, A to the B right there. It'll also take you up to the exponent. So, oops, we can get rid of these. All right. So the next thing we want to talk about is y-intercept. We're talking about exponential functions. So we want to talk about the y-intercept and our common ratio. And exponential functions, we're going to have a common ratio. So the y-intercept is going to be 6. Remember, this number here tells us where our y-intercept is. So as we're sketching this, we want to think like, okay, I'm going to mark where my y-intercept is, which is right there. If you want to write the coordinate points, this is going to be 0, 6. Okay. All right. The next thing is we want to talk about the common ratio. So the common ratio will be 2, and that tells us that we're multiplying by 2 every single time. So if I were to put this into Desmos, right, so let's go ahead and make that an X, make a little table here. We're going to turn this into a function so we can throw these values into our, whoops, that went just there. So we can throw these into our function. It's going to be X1. Perfect. All right. Oops, didn't mean to do that. All right, so 0, 1, 2. Okay. So what's happening here is our y-intercept is 6, and we're doubling every single time. So if we were to add another one, we're going to go double again. We're going to see it's going to look something like this, right? So we're starting at 6, we're going up to doubling to 112. We're going to double again. We're going to be at 224, 330, 348, and so on, right? We can also go the opposite direction. So if I want to go -1 for my x, right, so at -1, we're going to be at 3, right? So for multiplying, when we go right, we're going to be dividing, going the opposite direction, right? So if I want to go to -2, it's going to be 1.5. We'll cut that in half. It's going to be 0.75. So let's actually sketch that, right? Again, this is a sketch. It doesn't have to be perfect. So again, we can't go up to 12. So I'm just going to go left. I'm going to divide that. I'm just going to quickly sketch this. It doesn't have to be perfect. So our graph is going to look something like that. Okay. Easy peasy lemon squeezy. Okay. All right. So next problem. All right, this is going to be a linear function. We know it's a linear function because there's no exponents, right? We're not raising anything to a power. And this is in standard form. Remember, we have 2 different forms when we talk about linear functions. We had our standard form, which would look like this. And then we also had our slope-intercept form. So if I'm talking about slope-intercept form, I'm going to be looking for my y-intercept and my slope. If I'm talking about my standard form, we're going to be looking for our x-intercept and the y-intercept. And the way we do this is I'm going to go ahead and pull up my iPad really quick to make this a little easier for myself to write. There we go. All right, so what's going to happen is I'm going to take that original equation. If I want to find my x-intercept, I'm going to take that original equation. So we got 3x minus 6y equals -12. And when we're trying to find the x-intercept, we're basically plugging in 0 for y. So what I like to do when I'm doing problems like this, to really quickly do it, is normally I tell you to cover it up with your thumb, but because you won't be able to see what I'm covering up with my thumb, I'm just going to cross out the y. So we're going to be left with 3x equals -12. We're going to solve for x. Divide by 3. So we're going to get x equals -4. So my x-intercept is going to be the -4 or the point 0, sorry, not 0, -4, 0. I'm going to do essentially the same thing for the y-intercept, but instead of plugging in 0 for x, we're going to plug in zero for x. So I'm going to rewrite the equation. So we got 3x minus 6y equals -12. Right, again, remember I want to get rid of the x. So I'm going to be crossing out the x here. So we got -6y equals -12 divided by -6. So y equals +2, or the coordinate point 0, 2. Either way. So let's go back. I'm going to go back now. So we found this, right? We said that our x-intercept is -4 and the y-intercept is +2. There we go. All right, so we want to sketch this. Again, I'm just going to mark my points, right? I want to mark my point at x equals -4. Just on the x-axis, I'm going to mark -4. On the y-axis, I'm going to mark +2. And then to make this a little easier on myself to sketch it, I'm just going to extend these dots out. You don't necessarily have to do this. We only need the 2 points to graph a line. So if I go down, so if I notice I'm going down 2 and to the left 4, so I'm going to do the same thing, right, and mark my point. Now I'm going to do the opposite. We're going to the right 4 and up 2, to the right 4 and up 2. You just want to connect the dots now. Voila. Okay. All right. All right. So for this, we wanted to find our average rate of change between these 2 points, right? So what's going to happen here is we're essentially going to be finding the rate of change between these 2 points, between 0 and 2. So I'm trying to find my right triangle. This is what we did in class. Remember, the first method we talked about solving for this is we wanted to create a right triangle. This is straight from Delta Math. We're going to figure out our rise over our run. And we're just going to count, right? So we're starting at 0 and we're going to 1, 2, right? So my run for this is going to be 2. And I'm starting at 60 and I'm going all the way down to 38. So I'm going down. This is going to be 60 minus 38, which is going to be 22. But again, we're going down here. Remember, this is a negative slope. It's going to be -20 down 22. Let me try that again. Mouse glitched there for a second. All right, so we got -22 over 2. So if you simplify that, we're going to get -11. We got -11 there. Perfect. All right, so that was one method, right? So create a right triangle. The other method that we talked about was using our formula. And I'm going to go back to my iPad again, but we're going to write down these 2 points. It's going to be 0, 40 and 210. So we got the point 0, 40 and 210. We're trying to find the slope between those 2 points. We're going to use the formula for this one, which was y1 minus y2 over x1 minus x2. Right? And so what I'm going to do is I'm going to use blue to represent this point and red to represent this point here. And I just have to pick one. It doesn't matter which one I pick. So I'm going to start with 220. Right? So I'm going to write 20 first. The trick here is I need to make sure I put the 2 right below it, because that's going to go with it. So I'm going to write 2 right here, right? So if I call this y1, this has to be x2, x1. And if this is y1, then this over here is going to be y2. Let's change that color. I meant to write that in blue. y2 and x2. So this is going to be 40 and 0, and minus, minus. So we got 20 minus 40 is going to be negative. Oh, sorry, I was looking at the wrong point. This is not 220. This is going to be 210. That's what I meant to write. So we got to change this up just a little bit. This is 10 here. So we got 10 minus 40 is going to be negative 30. And 2 minus 0 is going to be 2. Negative 30 divided by 2 is just going to be negative 15. All right, so our slope for this problem is going to be negative 15. So if you don't feel comfortable using the formula, you can always use the counting method too, right? So if we wanted to, I can draw another right triangle. So just go down like this, go like this. My run is going to be 2. My rise is negative 30. So again, negative 30 divided by 2 is negative 15. So my slope for this one is negative 15. And the last question it's asking for is, I'm going to go ahead and erase some of this stuff so we can see this a little bit better. Is we're looking at, all right, so my points are going from 40 to 10 to, 40 to 20 to 10. And we're trying to figure out my common ratio for this. So as we're going from 40 to 20 to 10, you should be noticing that we're cutting this in half every single time as we go up in 1. So my common ratio, or my common base, is going to be, we're dividing by 2 every single time. The way we write that in our equation is going to be 1/2. Right? So if I were to plug this into the equation, I'm going to switch back really quick. I know I'm flipping back and forth a lot. So we got our y-intercept of 40. So we got y equals 40. But I want this to be 1/2 because I want this to go down. And I'm raising that to the x. Yeah. And if I make my table here, we have table. Delete that. Oh, shoot. Too much. There we go. Delete that. There we go. All right, so I'm just going to do 0, 1, and 2. All right, this is taking this 0 and plugging it in right here. So 1/2 to the 0 power is going to be 1, and then 1 times 40 is 40. Right, so then 1/2 to the 1 power is just 1/2. 1/2 of 40 is 20. 1/2 to the second power is going to be 1/4. Right? So if you don't believe me, 1/2 squared is going to be 1/4. 1/4 of 40 is going to be 10. Right, so that's how we got that 1/2. Okay. Like I said, I'm just quickly running through these. So if you have any questions, you can send me an email on the homework. All right. In the rest of the class, I gave you like the last 10 minutes in class to work on these last 4 slides. So we're working through this. The graph is a representation of money in your savings account, S of X. So this is going to be your savings account, and the blue line is going to be your credit card. Which account has more at the start? Right? Do you have a savings account, credit card, or neither? Right. So at the start, when X is equal to 0, the start, my savings account is going to have more money. Which account has larger value in the 3rd month? Remember that on the X values are going to be our months. So after 3 months, which is right here, again, my savings account is going to have more money. And then we look after the 6th month, the account has a larger in the 6th month right here. It's going to be neither. See how they're crossing right there? So neither has a larger amount. So let's go back to this one. Which one had more growth between months 2 and 4? Okay, so this one's a little tricky. So we're going to talk about this one for a second. So between months 2 and 4, right? So if I look at my slope between the 2nd month and my 4th month, that's going to be the slope right there. But if I look at the slope, my growth between these two, so let's actually try and put a number on this, right? So I'm going over 2, and it looks like I'm going up like, let's see, that'd be 80, 85, like, it's like 25. We're going up 25, give or take. So my slope is going to be roughly 12.5. Right? So if we look over here now, again, my run is going to be 2. But instead of going up by 25, we're now going up. We're starting at like 30, and we're going up to 55. So we're starting at 30, and we're going up to, let me make sure that's right. Yeah, 55. So that's going to be an increase of 30 to 55. That's going to be, wait, did I do that right? Are my eyes working right? 6 to, yeah, it's about like 25. And then we're going from like 30 to 55. So yeah, so about 25. To me, just by looking at the graphs, I'm going to say that the credit card one has a steeper slope. That's really what we're trying to look here. I feel like my eyes are not working, and I feel like I'm missing something here. But my line is going to be steeper with the credit card. Give me 1 second. Let me take a look at this. All right, 0. So it's like 80, like 85. So 60, that's like 25. Then we're going from like 30 to 50. It's a little more than 55. So I mean, they're really close. Like this would be like 12.5 and this would be like 13. It's not much. But I would still say that this line is going to be a little steeper. And the next thing I wanted to talk to you about was this one right here. Right, this is the one that tripped up a lot of my students in class. We had to talk about this in class. So which of the accounts shows an average rate of change that increases? The thing about lines is our average rate of change, it doesn't matter where I put it on this line. Like I can pick any 2 points and we're going to get the same rate of change. We're going to be increasing by the same thing over the whole entire span of that line. My average rate of change does not change. But when we're talking about exponential functions, my average rate of change is going to increase or change. All right, so if I take a look at this, if I draw a line here to here, and then from here to here, see how it's starting to slowly, I know it's not perfect art, but it's starting to slowly increase. So my rate of change is changing. In fact, it's growing faster and faster as we go through this. But my rate of change for this one, let's do this in a different color. Let's do this in like this awful green color. Like it's going to be the same line. It doesn't change. It's pretty much should be landing right on top of each other. And the only variance is going to be user error. Okay. So the account that it has an average rate of change that increases is going to be your credit card account. All right, so we want to order the following y-intercepts from smallest to largest, right? So we know this one's pretty easy. My y-intercept right here is just going to be 14. So if I can go ahead and graph that. So we got y equals, or f of x, and that's going to be 1.25x plus 14. All right, so as I'm increasing, it looks like my rate of change for this problem is going to be up by 1. So like if you look, I'm increasing by 5. My run is going to be 5 as I'm increasing. My rise is going to be 5. So my slope is going to be 1. All right, so what I'm saying is this is going to be how much I increase in my y. This is going to be how much my run. It's my rise. Here's my run. So my slope is going to be 5 divided by 5, which is just 1. So my equation is going to be y equals 5x, and we just need to figure out where we're going to be crossing that y-intercept. So if we go back 10, we need to subtract 10 over here. Right, so we're trying to get to the 0. So we subtract 10. We're going to subtract 10 here. So our y-intercept for this problem is going to be 15. So let's go ahead and write that. Let's put that in our graph that we're making. Let's call this our g of x function. So it's going to be x plus 15. And the last one, we just go ahead and look at where is my y-intercept. It's going to be 16, and it looks like my slope is going to be, let's see, how big is my slope? We're going up to, trying to find a whole number. There we go, right? If I can get it close, 422. So that means I'm going up to and over 4. So my slope is going to be 1/2. So the equation for this one's going to be 1/2 x plus, and then my y-intercept was 16. So let's go ahead and graph that. So we have h of x equals 1/2 x plus 16. And we're trying to write these in looking at our y-intercepts from smallest to greatest, right? So my smallest one is actually going to be letter A. So letter A is going to be the first one. And then letter B, because it's going to be this problem here, or the table. And then the last one is going to be the graph. So it's just going to be ABC in that order. Okay. All right, so we're given a standard form equation now. So what is the slope and y-intercept of the equation below? We have 6x minus 3y equals 9. Right, so what is the slope of the equation? Right, so there's two ways we could have done this. We can solve this manually, and we're going to do that. I'm going to do that algebraically. So we got, what is this, 6x minus 3y equals 9. Right, we're trying to find the slope. And the easiest way that I can think of to do that is to try and solve for y when we're doing it algebraically. So I want to get this by itself. So I'm going to subtract 6x from both sides. Right, the 6x's cancel out on the left-hand side, and we're going to be left with negative 3y equals negative 6x plus 9. We have negative 3 times y, so we need to divide. This reduces, so we're left with y. I'm going to go ahead and separate this, and I'm going to separate this right here at that plus sign. So we're going to have negative 6x divided by negative 3, and then plus 9 divided by negative 3. Because they have a common denominator, we can separate it out. So this is going to be equal to, let's go ahead and simplify this. Negative 6x divided by negative 3 is going to be, it's going to be a positive 2 times x. Then 9 divided by negative 3 is going to be negative 3. Right, so from here, we already have the answer, right? So we have our slope. Remember, our slope is going to be right here, and our y-intercept is going to be built right here. Remember, y equals mx plus b. So my slope is going to be 2. My y-intercept is going to be negative 3. The other way we could have done this is we could have cheated and we could have used Desmos. And I could just type in the equation. So the equation, remember our equation was 6x minus 3y equals 9. Right? So we could have been like, all right, so my y-intercept is going to be negative 3. There's my y-intercept right there. It's where we cross the y-axis. And my slope is going to be like I'm going up 1, 2, and to the right 1, which is going to be right there. Right? So that's how we got, that's another way you could have done it, which would have been 2 and negative 3. All right, and the last one. All right, so determine if the data shown in the table models a linear or exponential function. All right, so we want to pick, is it linear or is it exponential? So we're starting at 128, we're going to 32, and then 8, and then 2. And then we're going to 1/2. Okay, well, you can see that we're not subtracting the same. We're going down, so it's going to be some sort of, it's going down. Like the graph itself is going to be going down, but it's not like a constant rate of change. Remember we talked about that, I think it was 2 slides ago. Remember, this is our rate of change for lines are always going to stay the same. So this is not a linear function, right? So see how my rate of change is changing? So it's going to be an exponential function. And in fact, it's going to be, we're dividing by, what is that? That's going to be dividing by 4, right? So 128 divided by 4 is 32. 32 divided by 4 is going to be 8. 8 divided by 2 is 2. 2 divided by 4 is going to be 1/2, right? So you can say something like the common ratio is 1/4, therefore it must be a exponential function, or something like that. I mean, it doesn't have to be exactly like this. You can say like we're dividing by 4 every time, so it has to be exponential. We're dividing every single time, so it has to be exponential. We're multiplying by 1/4, so it has to be exponential. Something like that. Okay. All right. Well, that is actually everything we covered in the last 3 classes. So I'm going to go ahead and end the stream right now. If there are any questions, like if there's anything specific you want me to go over in a live stream in the future, let me know. I'm more than willing to help you out. Send me an email and we can go over it. All right, I will see you in class. Have a